Hi everyone, this is Mr. Almonte and again welcome to another episode of HALINA'T MATH-TUTO sa Dasmariñas North National High School YouTube channel. Our lesson is polynomial equations and today we're going to learn how to identify the degree and real roots of polynomial equations. See your module on page 31. Under the lesson Polynomial Equations, let's discuss illustrative example number 1. Considering the equation x minus 2 times 2x plus 3 times x plus 1 is equal to 0. Since the equation is presented as linear factors, using the zero product property, we have x minus 2 is 0, 2x plus 3 is 0, and x plus 1 is 0. Now let's solve each equation. X minus 2 is 0. Transpose negative 2 to the other side of the equation. Remember to change the sign. Then we have x is 2. Then 2x plus 3 is 0. Transpose 3, change the sign, so we have 2x is equal to negative 3. To find x, divide both sides of the equation by 2. 2 divided by 2 simply cancelled out, so we have x is equal to negative 3 halves. Lastly, x plus 1 is 0. Transpose 1, change sign, then we have x is negative 1. Now we have the solution of the given polynomial, which is x is equal to 2, x is equal to negative 3 halves, and x is negative 1. Now see your module on page 32 and let's answer learning task 1, 1 to 3. In this task, we are asked to complete the given table by identifying the degree and real roots of polynomial equations. Let's proceed to the first one. X minus 1 times x plus 2 is equal to 0. How to find the degree? The degree of a polynomial is the largest exponent on the variable among all its terms. Here, we are given a factored form. When we need to compare terms in the simplified form, you could multiply everything out. But that is not the most efficient thing. Simply recognize that the highest power will be obtained when multiplying the highest degree terms in each factor. In here we have x times x is equal to x squared. The degree of the given polynomial equation is 2. Next, how to find the roots? You can find the roots or solutions of the polynomial equation, each factor equal to 0, and solving for x. So we have x minus 1 is 0 and x plus 2 is 0. Just like what we did earlier, transpose negative 1 to the other side of the equation, change the sign, then we have x is equal to 1, and solve for the second one. Transpose 2, so we have negative 2. The roots of the given polynomial equations are 1 and negative 2. Lastly, how to find the number of real roots? Examine the highest degree term of the polynomial, that is, the term with the highest exponent. That exponent is how many roots the polynomial will have. So if the highest exponent in your polynomial is 2, it'll have 2 roots. If the highest exponent is 3, it'll have 3 roots, and so on. In here, we have 2 as the highest exponent. Therefore, the number of real roots in the given polynomial equation is 2. You can pause this video for a while to help you understand this example. Now let's resume and go to the second equation. 2x times x minus 3 times x plus 2 is equal to 0. So finding the degree, multiply all x in each factor. We have 2x times x is equal to 2x cubed. Then the degree is 3. Next, finding the roots, we have 2x is 0, x minus 3 is 0, and x plus 2 is 0. Now, let's solve for x. 2x is 0. Divide both sides of the equation by 2 to remain x. Then 0 halves is 0, so x is 0. Next, x minus 3 is 0. Transpose negative 3, change sign, then we have x is 3. Last, x plus 2 is 0. Transpose 2, change sign, then we have x is negative 2. The roots are negative 2, 0, 3 in increasing order. Lastly, finding the number of real roots is very simple. Just find the highest degree, then we have 3. The number of real roots is 3. You can pause this video for a while to help you understand this example. Now let's go to the third equation. X plus 2 raised to the third power times x minus 2 is equal to 0. Finding the degree, observe that x plus 2 is being raised to the third power, meaning x plus 2 should multiply itself 3 times to get its degree. So we have x plus 2 times x plus 2 times x plus 2. Multiply all x in each factor, we have x cubed times x is equal to x to the fourth power. The degree is 4. Next, finding the roots, we have x plus 2 raised to the third power is equal to 0 and x minus 2 is equal to 0. Now, let's solve for x. X plus 2 is 0. Transpose 2, change sign, then we have x is negative 2. Have you observed that x plus 2 is raised in the third power? The multiplicity of a root is the number of occurrences of each root, meaning x plus 2 occurred thrice. X plus 2 raised to the third power is equal to x plus 2 times x plus 2 times x plus 2. Therefore, the root is negative 2 multiplicity of 3. Did you get it? Good. Next, x minus 2 is 0. Transpose negative 2, change sign, then we have x is 2. The roots are negative 2 multiplicity 3 and 2. Lastly, finding the number of real roots is very simple. Just find the highest degree, then we have 4. The number of real roots is 4. You can pause this video for a while to help you understand this example. I believe you are now ready to proceed with the rest of the learning task, and I hope these first 3 examples will help you get done. Thanks for watching this video. Don't forget to like, share, and subscribe to watch our latest math tutorial here in HALINA'T MATH-TUTO YouTube channel. Thank you.